Welcome to the Async Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Hello everyone, welcome to another episode of the Async Coding Interview Data Structure series. So, in this episode, we'll be looking at a data structure named queues, and this episode is going to be packed with resources and insights. So, stay tuned and pay rapt attention to what is displayed. If this is your first video on this series, I advise you to go back and watch the previous episode. So, as usual, I start off with the definition of the queue data structure. A queue is a linear data structure with its nodes arranged sequentially. Its modification works with the FIFO principle, which means first in, first out, where the first node in is always the first one out. It's just like in the real life scenario of a queue in the bank, the first person to start the queue is always the first person that goes out. It is the direct opposite of the stack data structure. So it's like the nemesis of the stack. While the stack implements last in, first out, this queue implements first in, first out. So this is a picture depicting what a basic queue looks like. So this is a simple queue. So you can see each of the nodes are arranged adjacent to each other sequentially. So that's the two operations that affects the FIFO principle. That's the first in and the first out. The enqueue adds a node to the queue, and the dequeue removes the node from the queue. So as you can see, the first in, which is this one that is going out, and then the last in is always the last out. So this is just an image, a visual representation of the queue. So as you can see from this image, the queue data structure is very similar to a queue in the real world. So like we see queues in our day-to-day life, like when we go to buy something from a stall, when we go to withdraw money from the bank, we meet queues, and the first person inside the queue is always the first person out, while the last person inside that got into the queue is always the last person out. So this is just like a real life representation of the queue data structure. So here are the applications and uses of queues. One of them is that they play a huge role in asynchronous computer operations. So those operations are going to be carried out asynchronously. They always get put in the queue before they are evaluated or before they are carried out. And if you're used to asynchronous JavaScript, you will discover that queues are what are used to solve those functions store those functions are asynchronous. So the next thing is that they are used to implement algorithms such as breadth first search algorithms. So when queues are traversing a particular breadth, when the pointer is traversing a particular breadth, queues are used to store the nodes that are already crossed. Those nodes have already been checked. So queues are what are used to store them. So they are used in instances like CPU scheduling. So processes, our computer carries a lot of processes. So queues are used in the CPU to schedule many processes and many tasks. Queues such as concurrent queues are used for multi-threading in application. So concurrent queues are used to carry out this multi-threading feature that you see in many web apps, even in many desktop apps, and just many applications at large. Queues are used to manage tasks like job flow in a system. So in every system, queues are used to manage how jobs flow, whether it's do two tasks at a time or do one task at a time. There's always a queue that is always keeping check of that. So queues are used to manage traffic and requests on a network. So queues act like, let's say, buffers that controls how data packets are sent to each network node, and also it kind of handles how requests is sent to each network node. So next up, we look at the three types of queues. So these are the three types of queues, the three major types of queues. Under these three types of queues, there are different variations of them. So the first one is the linear queue, and I'm also going to be doing like 3 episodes of these 3 types of queues, and we are going to explain to each variation of these 3 types of queues. So the first one is the linear queues. Just like the simple definition of queues, the linear queues are just queues which operate the let's call it the FIFO, I mean the first in and the first out, and also it's linear. That means it takes one node at a time. Though under these linear queues, there are variants that don't operate with the FIFO. So we'll be looking at it in the next episode. So why it's called linear is because its nodes are arranged sequentially. The next queue we have is the priority queues. So this queue, it doesn't operate on the FIFO. It's how it works is that they queue with the most priority, whether you're using ascending priority or descending priority. So the queue with the node with the biggest priority is the first one to be handled and taken out, and that's how it keeps going. That's in the ascending priority, but in the descending priority, the ones with the smallest values that are taken out first. So the next kind of queue we have is the circular queue. So this queue is very interesting because it doesn't actually remove nodes. In fact, it repeats itself in like an infinite while loop. Something like the traffic lights we have. Once it goes from red, it goes to yellow, it goes to green, it goes back to red. That's how the circular queues work. It's cyclic. It just moves around the nodes of the queue. So we'll be looking at these queues in the next episode, starting with the linear queues, and under it there are many variants. There's the double-ended queue, there's the inputs restricted queues. So we are going to meet them, and it's going to be very interesting. So thanks for watching this episode, and anticipate for the next one. Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I will be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.